Hey gang, welcome to the sixth video in our Rust for beginner series. In this video, we will learn about the various data types present in Rust and how we can interact with them. Before we jump into it, if you guys haven't subscribed to the channel, please do so, as it helps me out a lot. If you guys have found the content interesting and would like to see more, please smash the like button and share with your friends who would benefit from this. If you guys have any doubts or any feedback for me, please do mention it in the comments. I will definitely look into it. Okay, let's get into it. Every value in Rust is of a certain data type, which tells Rust what kind of data is being specified, so it knows how to work with that data. Rust is the statically typed language. This means that the type of variable must be made known to the compiler. The compiler can usually infer uh, what type we want based on the value and how we use it. In some cases, multiple types are possible. For example, last time when we converted in the previous video where we converted the input from the user in the form of a string to a integer. So here, the value could either be an integer or it could be an error. So you have to uh, explicitly tell Rust that we need U32. Otherwise, it has to throw an error. So that is what we do here. The U32 that we give here is called type annotation. In this, like what I said before, in this case, the compiler won't be able to automatically infer what type of data is being returned by this expression. And if we do not mention this, we will get an error while compiling. Now, data types can be of two subtypes. One is scalar types, which represent a single value. Rust has four primary scalar types: integers, floating point numbers, which are decimals, booleans, and characters. If you have prior programming experience, you might recognize them from before. Compound types can group multiple types into one type. Rust has two primitive compound types, tuples and arrays, which we will get into later in the video. Now let's see how scalar data types work in Rust. Integers. An integer is a number without the fractional component. The table shows built-in integer data types present in Rust. We can use any of these to declare the type of an integer value. Now, integers can either be signed or unsigned. Signed integers can hold negative numbers. Unsigned integers can only hold 0 and positive numbers. Now, unsigned variants can hold numbers from -2 to the power of n minus 1 to 2 to the power of n minus 1 minus 1, where n is the bit length. For example, I8 can hold values from -128 to positive 127. Unsigned variants can hold data from 0 to 2 to the power of n minus 1. That means, for example, U8 can hold 2 to the power 8 of 0 to 2 to the power of 8 minus 1, which is 0 to 255. Now, this last entry that we see here, I size and U size, they depend on the system architecture. For example, a machine with a 64-bit machine will have U size be equal to U64, and I size will be I64. A 32-bit machine will be U32 and I32. Most modern systems are 64-bit, so it's usually U64, but don't take it for granted. Now, integer overflow. Now, for example, if we have a variable of type U8 and we assign 256 to it, now this is an error because U8 can only hold 0 to 255. So the compiler will check and will throw an error and will not let us compile the program, since it will lead to runtime errors or logic errors later. Floating point data types is used to store decimal numbers, such as 1.23, 0.56, minus 13.6802. Now Rust provides two types, F32 and F64, which is the 32-bit and 64-bit. The default type is F64, since on modern CPUs, it is roughly the same speed as F32, but it's capable of more precision. All floating point types are signed. That means you can have positive floating point numbers, negative floating point numbers. There is no need to add UF or IF. It comes default. Now, this is how you generally declare a floating point number. Let x equal to 2.0. This will create a F64 by default. Now, if you want F32, you will have to mention it explicitly. See, x F32 will create a 32-bit floating point number. Now, Rust supports basic numeric operations that you'd expect for all number types. Sum 5 plus 10 will add the numbers, difference 95.5. This will give you the subtraction. Product 4 into 30 will give you 120. Quotient. Now here it's a little different. If you use two floating point numbers, it will give you the exact quotient. But if you use two integers, now minus 5 divided by 3 is minus 1.667. And I mean, it keeps going on. But because these two are integers, this will also, the truncated value will also hold only an integer. So it will hold only the integer part of the result, which is minus 1. Now, if you want remainder, so 43 remainder 5 will be 43 divided by 5 is 8, and with a remainder of 3. So the remainder will be stored in this value, which is 3. As in most programming languages, a Boolean type in Rust has two possible values, true or false. Booleans are mostly used through conditionals, such as an if expression. We will cover these soon. Character types. Characters are represented in strings using single quote. Strings are usually double quote. Characters take up 4 bytes and represent a Unicode scalar value, which means it can represent a lot more than ASCII characters such as 1, 2, 3, 4, A, B, C, D. It can even include Chinese, Korean, Japanese characters, emojis. We will learn a lot more about this in a later video about strings. Okay, now let's look at compound types, tuples. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values inside parentheses. Each position in the tuple has a type, and the type of different values in the tuple do not have to be the same. For example, here 500 is I32, 6.4 is F64, and U8 is 1. See how this works. Now we can also access a tuple element directly by using the period. For example, here 500 can be accessed by x.0. That will give you the first value. Tuples, the index always starts with 0, 1, 2. Now if we run this code, open up the terminal, cargo, run. Yeah, so now we get 500, 6.4, and 1. We have one more type of tuples called a unit tuple. These are tuples which do not have any value They are used to represent an empty value or an empty return type. Expressions implicitly return the unit value if they do not have any other value. Arrays. Another way to have multiple values is an array. Unlike tuples, every element in an array must be of the same type. Arrays in Rust have a fixed size, they cannot grow or shrink. We write arrays as comma separated list in square brackets. Arrays are declared like this. First, you have the type and then the length of the array. Arrays are useful when you want your data to be allocated on the stack rather than the heap. Rather, more on this later, but essentially, data stored on the stack is faster to access, but comes with certain limitations. Arrays are more useful when you know the number of elements that have to go inside them. For example, if you need the number of all the months in a year, so those will always be 12. So that you can use an array for. Now now we can declare an array by as in the previous code. Let's write let a equal to we don't have to explicitly annotate the type here because okay, this my editor has already done this, but it the compiler is able to understand this that this is an i32 of 5 elements. Now, if we want to access the first element, we do let first equal to a similar to how we do it with tuples. Index starts at 0, but we use the box brackets to access the element. Let's second be equal to a1. Run this, save this and run. Okay, yeah, sorry. If you leave a bracket here, it looks like it's 12 when it's actually 1 and 2. Now I have a challenge for you guys. Like in the guessing game video, I want you guys to accept an input between 0 and 4 and print out the element in the array based on user input. Pause the video here and come back to compare your result to mine. Were you guys successful? Okay, let's go about this. Now we'll use the same array that we used here. Let's say println, enter an array index. Let me index be equal to string. We need to keep it as a string since we are accepting input from the user. Before this, we need to uh, bring the standard input output to the scope. And now we need to handle the error if we are unable to read from the input. You can keep it as u size, you can keep it as u8. Let's keep it as u8 equal to index dot trim dot pass dot expect. Now the parse will convert it to a U8. Invalid number. Let yeah. So what we're doing here is we accept the input from the user, convert it to a integer, extract the element from the array, and then print it out. Oh, sorry, it has to be use size. Okay, let's put 2, and that is correct. Now say we put 6. Now the program panics because the length of the array is 5, but we are trying to access something in 6. So this will be an error, which you can control here, say using the index and match expression that we had done earlier. Okay, that's it for this video, guys. In the next video, we will be looking at functions. If you guys like this video, please subscribe to the subscribe for more videos. Thank you, and see you in the next one.